Hi, in this video I'm continuing my discussion on partitioning with SQL Server, and I'm going to go ahead and use a couple of scripts that I've created to kind of demonstrate the concepts as well as show you in detail exactly the difference in performance between the different systems. So the first thing we'll do here is we'll go over the scripts and then I'll start executing them. While I'm executing it, we'll pause the video because it takes a significant amount of time to load about 8 million rows of data, but once it's done we'll go ahead and explain exactly all the queries that are going on behind it. So as you can see here, I've got two sets of scripts here. The first one is unpartitioned indexed table, and the second one is a partitioned no index table. And we're going to go ahead and do both variations of this, the reason for that being that we can demonstrate how partitioning can actually help improve performance. So the first thing we'll do is we'll go ahead and just look at the script. As you can see here, I start off by using the master database and creating a database called partition test 122. I use this partition table to create a table called unpartitioned table, which as you can see here contains a significant number of columns. Once that's done, I bulk insert data from a file called data.csv, which is located on my C drive, and this CSV file contains 1 million rows of data. Once I've imported that one time, I go ahead and run this in a batch. It goes ahead and implements it 8 times, so therefore I have 8 million rows inside this table. Once we have the 8 million rows in the table, the next thing I'm going to do is I'm going to run this set of scripts here to kind of baseline the performance that we get for 3 different types of queries on the heap table as it is. And then once that's done, I'll go ahead and create a clustered index on REF, and we'll try different other couple of different other scenarios. And once that's done, we'll see exactly what kind of baseline and what kind of values you're looking at. Once this is done, the next step that we're going to do is we're going to go ahead and run the partition no index. As you can see, I'm creating a separate database. It's called partition test 123, and then in this particular table, or in this database, what I'm doing is I'm creating different file groups for the ages 25, 26, 27, 28, 29 and 30. Now in my data I've got ages ranging from 1 till 99, I guess, but I'm not going to go ahead and create 99 partitions to just demonstrate this concept in the video. I'm just going to stick with about 4 or 5, and if you can do it for 4 or 5, you can do it for 99 as well. And as you know, there are quite a lot of partitions you can create for a table, so 99 is not like an upper limit. Obviously each file group will have its own dedicated file. As you can see, a secondary NDF file 1, 2, 3, 4, 5, 6 belonging to partitions 25, 26, 27, 28, 29 and 30. And then we have the partition function, which will kind of help us segregate the data, and then the partition scheme, which will help us map the segregated data with the individual file groups. Once this is done, the next thing I'm going to do is, as you can see here, I'm creating a table called partition table instead of unpartitioned table as we did with the previous script. And again, just like before, I'm inserting from data.csv 8 million rows into the table. Once the 8 million rows are inserted, we're going to do a count star to verify that 8 million rows are there, and then these are the exact same queries that you saw before. So you can see here the first thing we're doing is a simple count star to just do a count of entire rows in the table, and then we've got group by ref underscore age comma count star, and then we've got select star from partition where ref underscore age is equal to 30. So you can obviously do more different other queries as well, but to demonstrate the concept about partitioning being able to improve performance, I've tried to stick with these. You can write your own queries. I'll show you where you can download the data and things like that later. So let's get started. We'll go ahead, use master database, and I'll select the script all the way up till here and create my table. You can see that I'm creating it on primary because I don't have any file groups other than the primary file group here. I'll refresh the database and you can see here that I've got my single table here. And now that that's done, I'll go ahead and bulk insert the data 8 times into the table. So at this point I'm going to pause the video. Once it's done, we'll come back and we'll start looking at this data. We'll run a couple of these scripts and verify exactly what kind of performance improvement we get. And I'll also show you the execution plan as well. Okay, so as you can see here, the execution is completed and we've got 8 executions done, and we've got a total of about 8 million rows inside this table. At this point, I've not yet run the statement to create the index, so what we'll do next is we'll go ahead and baseline what kind of performance we get for these queries when we just do it on a basic heap, no indexing of any sort. So I'll just open up Excel here so that we can keep track of the numbers that we are generating. So I'll just call this heap, and I'll just call this Q1, Q2, and Q3 for the three different queries that we have here. And what we'll do is we'll run this 3 or 4 times, and then we'll just kind of take an average of whatever numbers that we get, basically. So as you can see here, I'm cleaning the buffer pool each time before I run this, mainly to make sure that there is no legacy artifacts of any kind from the previous execution. You'll also notice that before every execution there is a execute statistics on, set statistics on, just to capture the time. So let's go ahead and run this. The first one, as you can see here, is basically a count star from the partition 112 database and the unpartitioned table. So let's go ahead and run this. And let's see how long it takes. As you can see here, it took 6 seconds on the heap table. So we'll go ahead and run this 2 or 3 more times, just make sure that we get some kind of consistent results. Okay, so next what we're going to do is we're going to go ahead and execute the queries on the table, and this time what we're going to do is we'll just take the first batch, execute it a couple of times, see what kind of results we get, and we'll do it for the rest as well. So to kind of keep things simple, what I'll do is I'll just go ahead and execute all of these in one shot. As you can see here, I've just got the table at the moment, and there's no indexes, nothing of that sort. It's not partitioned, it's just the static table as it is. So let's go ahead, select all of this and execute it, and we'll baseline, or we'll capture the numbers here. So I'll just open up Excel, and we'll just keep track of the numbers here. So I'll just call this Q1, and I'll just call this T1, T2, and T3 for the 3 trials that we'll be doing for this one. And then we got Q2 and Q3, which is basically the 3 queries that we have. So it's still executing, but let's see what kind of numbers we have here. So we've got about 7.3 seconds here for the first iteration, and then we got 7.2 for this query here, and then we've got 27 seconds here for the last one. So I'm just going to go ahead and plug that in. So let's say 7.3 seconds, 7.2 seconds, and 27.6 seconds. That's our first iteration. We'll go ahead and run this again, and we'll just see what kind of numbers we get the second iteration. Hopefully they'll remain exactly the same or very close to the first iteration, so that'll kind of give us a good solid benchmark against which we can measure the performance. Okay, so it's close enough. I'll just open up the Excel sheet here. So again, we've got 7.0, and then we got 7.1, and it's still executing the third part of the query, so we'll just wait for that to complete. Okay, and 27.7, so close enough, 27.7. And we'll just do this one more time just to make sure that best out of 3. You can obviously hear my CPU is starting to act up, so that's kind of what you'd expect with the data warehouse table and the querying that goes on behind it. Guess it's almost done. So let's go ahead and note these values in as well. So we've got again 7.6, and then we've got 6.8, and we've got 27.4. So I'll just put this over here as a average, and we'll just measure the others against these numbers that we have here. So at this point I have a baseline for unindexed heap table. So I'm just going to call this guy heap, and what we're going to do next is I'm going to go ahead and create a clustered index on the ref underscore age column, which is the column that we're using here, as you can see. So we got ref underscore age is 27. It's also part of the group by statement. Here again we're filtering it, and then we've got a count star. So in order to do that, as you can see here, I've got to create clustered index ref underscore age on this table, ref age ascending. The rest of it is just the defaults, and the reason I've left it at defaults is to kind of show that clustering partitioning works out of the box. It's not something specially configured or some magic tricks that you need to use to get it to work and be better. So that's the reason why I've left everything in the defaults. You'll see that in my scripts again, when I create the database, I've not really specified anything, so it's just using the default of the database itself. So this index creation is going to take a few minutes as well. So again, I'm going to go ahead and pause the video, and when we come back, we're going to rerun these scripts that we just did, and we're going to compare the performance. So I'll go ahead and pause the video now. Okay, so as you can see, the index creation has completed successfully. So if I refresh this table now, I should find a clustered index on ref underscore age column. So now we have that. Let's go ahead and rerun these queries again. This time, let's see what kind of improvement or degradation performance we get. So again, I'm going to execute this. I'm anticipating that there might be a change in execution plan, so we'll just wait for it to complete, and then we'll just start capturing the numbers after the second execution. Shouldn't really matter because the numbers are anyway not going to keep the parsing and syntax check, the optimizer's time overhead. It's going to just capture the data overhead. So either ways, we should still get consistent results, but let's see what kind of numbers we're looking at. So to start off with, you can see that the very first statement, which is our select count star from, is now significantly larger compared to what we were doing before. So you will see that counting rows in the table has now suddenly become very expensive. So you'll see that it's 22.74 seconds. Now the thing to keep in mind is that I created the clustered index after the data was loaded, so there's literally no fragmentation in the index. This is just the heap in itself. So at this point you can see that it's 22.745. So I'm gonna go ahead and just capture that over here. So the first execution over here is for the clustered index now 22.74, or 22.7 should be good enough. And then we see an improvement in the time taken to fetch the data, where ref underscore age and the count, basically the second part of the query that we see here, has come down to about half with 3.067 seconds. So that's definitely good for us, because at least it's telling us that adding the index is not completely pointless. At some point we do get some benefit. It's probably not for all cases. But let's go ahead and look at the last one, which is 21.315, which also seems to be an improvement, because I think the previous case it was about 27 seconds. So an improvement of about 7 seconds, which is pretty good, considering that it took significantly longer when we were doing a count star. So let's do this. Let's run this a couple of more times. Actually, not a couple of more times. We're going to run it a few more times, and let's see whether these numbers change for the better or worse. And that'll give us a baseline in terms of what kind of performance we're looking at when we have an index or a clustered index on the table. So we'll just wait for that to complete. As you can see, again, the time taken for doing a count star seems to be pretty massive. In this case, it's about 15.7, which seems to be a good improvement compared to what it was initially. So that probably explains about the execution plan and the statistics that need to be created. But either ways, we'll go ahead and run it a couple of more times just to make sure that we get consistent results. So I'll just capture this number in anyway, but if we get a better, more consistent result, I'll override the previous value with the new value. So this time the execution completed, as you can see here, a little bit faster than before. So let's go ahead and capture these numbers in. It's 15.7, 2.7, and 21.4. So you can see that the last two queries seem to be consistent in their execution times. It's the first query that isn't. So we'll keep running this again until we get all three of them to be remaining fairly consistent. Okay, again, it's close to about 15 seconds, so I think at this point we've got a scenario where all three queries return consistent results. So we'll just run this one more time just so that we can get the baseline for the first trial that we did, and then we can move on to the partition tables. So while this is happening, let me go ahead and make a note of these numbers. It's 15.5, and then we've got 27 point, I'm sorry, 2.7, and then we've got 21.4. Great, so that's this one. We'll just run it one more time so that the first trial gets a more consistent number, because as you can see here in the first trial, uh, it's in the first trial it's 22.7. Okay, oops, Visual Studio pops up there, so let me just go ahead and um, come back to SQL. And here, as you can see, again it's 15.8, so that's good. So we're starting to get consistent results. So I'll plug this in here, 15.8, and then we got 2.9, and let's see what the last one is going to be, 21.7. Okay, great. So now that we know the numbers between or the comparison between the clustered index versus uh, a heap table on its own, it's pretty obvious that the clustered index doesn't really give us any benefit. It doesn't give us any benefit. In fact, it makes things worse when we're doing a count star of the number of rows in the table, which is, I guess, a fairly common requirement as far as data warehouses go. But either ways, you can see that the remaining two queries, as you can see here, did improve marginally. I'll just go ahead and do a comparison here for the sake of just clarity. So let me just do this. I'll just go ahead and call this guy improvement, and I'll take this number and divide it by this number. Great. So as you can see here, what we're looking at is not really significant improvements as such. You can see that in this case it came down to about half, which is fine. And here, if you look at it, 21 to 78%, we're really seeing an improvement of about I don't know, 20%, right? So let's go ahead and now do the partition table, and we'll compare these numbers again with the partition table. Now I will come back to this again and create a non-clustered index as well, but the initial understanding or the initial discussion was around how partitioning can actually give any kind of performance benefit, and it's always the clustered index because of the way that it works with the data that gives the index, that gives the improvement. So in this case, let's go ahead and now run the script for creating the partition tables. So you'll see here I'm leaving the other table database as it is, because in case I need to come back and show you some more comparisons, I can do that. So let's do this now. I'll create the other database. You can see that it's called partition 123 as opposed to partition 122. And once that's done, you can see that we've got 123. And I'm going to go ahead and create these files, that files and file groups basically. So how do we know that it's there? You can query the DMVs, or you can just right click and you can see here I've got all my file groups here, and I've got all my files here. So that's good. So now that we have those guys, I'm going to go ahead and create the partition function and the partition scheme, which I've already explained how they're splitting the data for ref underscore age at the beginning of this video. Now that we have the partition function in the partition scheme, I'm going to go ahead and create the table. So if I scroll right down to the bottom, you'll see that instead of creating it on primary, I'm creating it on partition scheme, where ref underscore age is the column on which the partition key is being implemented. Now that the table is created, let's run the bulk insert. So I'm going to start this, and we'll wait until 8 million rows are loaded, and then it's time to see the results of partitioning. So I'm pausing the video at this point, and I'll come back once the data is finished loading. Okay, so the batch process is completed, and we have finished loading 8 million rows into the table. So in this case, luckily for us, we don't have any overhead of creating the index, because the intention here is to compare a partitioned unindexed table, which is basically just a heap that's split into many different files, and trying to compare the performance of that versus a monolithic table that's got an index on it. So let's go ahead, we'll select our query, and we'll start executing it, and we'll start capturing the numbers. So just go ahead, put it, keeping this ready over here. So I'll go ahead and create another set here so that we can kind of monitor the performance, and I'm just gonna call this partitioned. Should be good enough. Oops. Great, and these numbers obviously don't belong here, so we'll remove them. And great, the query is finished executing. So let's look at the numbers here. So we've got, for the first query, 5.6, which is significantly better than what we were getting with with the clustered index. But we'll go ahead and plug it in. Let's see if the numbers change later on. For now, we'll just take it in as it is, 1.2 seconds, and then we got 23 seconds. Right. So let's run this again. And while it's running, I'll just quickly confirm that everything is as we expect. So while it's refreshing, I'll just come here. You can see that I've got a table. I've got under storage, I've got my partition scheme and my partition function. And if I right click and go to the properties of the table, I should find that it is split by the partition key, partition scheme 1 for column ref underscore age. So yeah, everything seems to be exactly like what it is in the script. All we need to do now is verify the numbers. So already it's okay, it's done executing. So let's look at the numbers. Let's plug it in here. So again, we've got 5.6, and then we've got 1.1, and then we've got 22. So we'll run this one more time. It's already done the first two queries, so let's have a look at that. 6.3 and 1.2. Guess if we wait a few seconds, it might actually finish the third one, and we can plug. Yeah, it's all done. So let's go ahead and plug this in now. So again, we've got 6.3, and then we've got 1.2, and then we've got 21. So let's compare these numbers one below the other, just so that it's easier to kind of see how things look. So as you can see here, when we did a partition table, what we're seeing is that there is a significantly better improvement in terms of doing count star from the table. You can see here that, you know, the performance is basically, let's do this, 1 minus this divided by this. Right, so you can see here that there's a 64% improvement. So that's actually not a bad number. In fact, I think probably the better thing would be for me to do it like this: 1 minus this number, the average number. Oops. 1 minus the average. Okay, does it not work that way? Unfortunately, my Excel skills are not as good as my SQL skills. So what we'll do is we'll do 1 minus average of these guys. Oops, okay, it's being treated like a string, so that's why. So let's see if I can get this to work now. So 1 minus this number divided by this number. Yeah, so 62% improvement compared to what we were seeing before, right? So actually, sorry, let's do percentage improvement if I'm doing it that way. So this is supposed to be the old number minus new number divided by the old number. So it's supposed to be equal to this number minus, oops, this number divided by this number. Yeah, okay. So either way, looks like we get the same answer. But you can see the bottom line here is that there is a significant improvement in the 3 times improvement in the performance between these two machines, these two systems, right? So if you just take this number and divide it by this one, that'll kind of give us the improvement basically. So this is the first thing. Now the next thing we need to do is compare for the second query here. Now in the second query again you'll see that this one had an index, so it wasn't really fetching all the data in the table. It was looking specifically for data for a specific range of 25 to 30. And again what you'll see here is that even in that case where the index was supposed to basically just filter for a very small portion of the data, and even then not really fetching all the columns, it's just doing ref underscore age and then a count star from the table. As you can see here, the partition table was actually able to give us a significantly better improvement compared to this one. It's almost like 50%, I'd say, uh, just looking at it right up the top. So again you can see that the partition table wins out in terms of the first query as well as the second query. Now the third one, if you look at it, you'll see that it's too close. You can see that it's 21 21. So in this case the partitioned table was giving us similar or equal performance as the clustered index. So this is the query that's for the second one, as you can see here. So we've got select star from partition 1 to 3 partition table, where we're looking for all the columns and only where they meet only the rows that meet the criteria where ref underscore age is equal to 30. So as you can see here, when it came down to this last query, you'll see that the partitioned table did give us similar performance as the clustered index and was both better than just querying directly off the heap. So in all 3 cases you'll see that the partitioned table gave us a performance improvement for all 3 scenarios that we were looking at, whereas the clustered index gave us performance improvement of a certain percent over the heap table only in 2 cases. But regardless, the partition table was always better than the clustered index whenever it came down to querying, and always better than the heap table as well. So I hope this clarifies exactly what I was trying to prove in terms of why partitioning is actually better and why partitioning does actually improve performance. You can see the numbers here. So again, the fact that they're consistent after 3 tries mean that there's no spikes or anomalies in the data itself. So this is basically the demonstration of what we were trying to prove earlier in terms of how partitioning is actually better than a heap and even better than a clustered index if you've implemented it properly. So now that this is done, what we're going to do next is we're going to add a non-clustered index on the table, because that's again one suggestion that I had actually been given. So I'm going to go ahead and create the non-clustered index, but before I do that I need to do it on the primary key column. So I don't have one on this table as yet, so I'll come back to my main table here, which is the unpartitioned table, and I'll say alter the table unpartitioned table, and I'll say add ID column, which is an integer value of identity 1 comma 1, right? And let me just go ahead and execute this. Now this is going to take some time, so I'm again going to go ahead and pause the video, and when we come back we're going to go ahead and create a non-clustered index on this table, on this column, and see what happens. Okay, so as you can see the query is completed and I've got a identity column on this table. So if I refresh the table and just look for the ID column, I should find it somewhere further down. So there we've got the ID column. The next step is to go ahead and create a non-clustered index on this table or on this column. So let me go ahead and do that. You should excuse me if I keep saying go ahead quite frequently. It's just something I can't seem to stop or help myself. I just can't control myself when I say go ahead. So let me just go ahead and do this. Ref underscore age. Actually, not ref underscore age. It's going to be ID. So I'll select add, and that comes here. And if I scroll down, HI, we got I over here. I'll script this just so that I don't get any timeout issues. There we go. So now that I've got it scripted, I'll cancel this one, and you can see here I'm creating a non-clustered index on the primary key, or a unique column basically. Yeah, so I'll just go ahead and select this and press execute. Oops, it's on master database. Let me change that. Okay, again, this is going to take some time, so I'm pausing the video. I'll come back and, oh, well, it's done. Excellent. So since this is done, let's come back to our query. We had the partitioned indexed column table, as you can see, a partitioned, oh, sorry, unpartitioned indexed. So this is the table that we're looking for. Let's select all of this and execute this, and let's see what kind of numbers we get. So you can see here 2 milliseconds, 4 milliseconds, and this is still executing, so we'll just wait for it to complete. Great, 21 milliseconds. So let me select all of this, execute it again. And you can see here that it's 473 milliseconds. And then we've got, oops, I guess the DBCC got mixed up in this, so that's again showing up here. It's actually 1.1 seconds. So let me just select this, get rid of this here. You can see that the DBCC drop clean buffers actually came in here to give 3 milliseconds. So I'll select this, run it again. So you'll see that the count star has definitely improved after the clustered index, and you'll also see that 955 milliseconds is what the 1 second is basically what it's taking now for the non-clustered index seek on the column that we're looking at the moment. So essentially by creating two indexes we were able to bring this down to about 1 second, whereas here without actually doing anything it was already about 1 second when we were doing partitioning. Definitely a big improvement in terms of the time taken for count star from, no doubt about that, but the rest of the time, as you can see here, remains fairly consistent at 21 seconds. So let's run this a few more times, just make sure that we get doing it right. You can see here 9.1 seconds, I'm sorry, 1 second, 900 milliseconds, 436. This is really the big improvement here with the non-clustered index. But again, the question you need to ask yourself is, you know, for a very large table, how do you see this actually panning out? You can see here 21.661 seconds. So pretty big deal here in terms of the performance. You'll see that after adding the non-clustered index, we're definitely getting better performance improvement when it comes down to the count star. But the rest of it remains fairly same, I'd say, because 1 second, 900 milliseconds roughly is what we're looking at here anyways. So let's do this next. We'll create the non-clustered index on the partitioned table as well and see what kind of results we get there as well. So I've gone ahead and created a column called ID integer identity column on partition table, and the next thing I'm going to do is I'm going to go ahead and create a non-clustered index on the ID column. Now the reason I'm going to do the non-clustered index on the ID column is because if I use a clustered index, that kind of is going to do the same thing. It's going to rearrange the data, and I don't want to do that at the moment. So for this purpose, what I'm doing is I'm going ahead and just saying non-clustered index on the ID column, because that is what we did for the other table as well. So non-clustered index, and click add, and we've got ID somewhere. Now the thing here is that I'm not using the ID column anywhere in any of these queries, so I don't think they're going to make any difference here with regard to the performance of the query that we have at the moment. But again, having said that, uh, you'll see that by creating the right index, you'll actually be able to get the performance to improve. So let's do this first. Let's create the non-clustered index on the ID column here so that we can rerun our queries. Great, so that's done. So now that we come back here, we'll select all of these guys and we'll execute this one more time. You will see that now I'm using the partitioned non-indexed um, table or scripts basically. So here, if you look at it now, you'll see that we've got significantly better performance. You can see we've got 736. So let me just get rid of this. There is a dbcc drop clean buffer executing here, which is this guy here after it finishes executing. So statistics time on, off, on, off, on, off. Cool. You can see the parse and compile time is 15 milliseconds, the parse and compile time is 9 milliseconds. So for the first query, you will see here that it's 763 milliseconds, which is better than what we were getting before. And you'll also see that the execution time for the second query, which was the one with the age between 27 and 30, you'll see that that's also down to 600 milliseconds as compared to the other one, which was 900 milliseconds. And the other one, the one that we're doing, select ref range is equal to 30, that remains consistent, so it doesn't seem to be benefiting from any of the indexes we're creating. But let's do this. Let's execute this whole thing again, and just make sure that we're getting the same numbers consistently. So you can see that after partitioning, after we did the partitioning, when we went ahead and created the non-clustered index on the primary key candidate column, we are getting even better performance than with just the partitioning on its own. So you'll see that again 700 milliseconds, and then we've got 578, and then we've got 22.17. So this guy seems to be approximately half of what the other query was over here. So you'll see that this was 919 milliseconds, whereas this guy is 578. So one last run just to make sure that we cover our basics. And once that's done, what I'm going to do is I'm just going to wind up this video, because I think at this point we've tried all the scenarios and we've got all the numbers documented on the screen. So again, 758, 573. The scripts and everything else is available. I'll go ahead and show you the links and things like that later on. But at this point, I think it's fairly clear that what we're looking at is basically the improvement in performance. So having said that, the whole reason why this discussion came about is because of a discussion that we had on one of the SQL Server Central forums, where someone suggested that partitioning doesn't give the improvement, and it's all about the the indexes that you create on it. So you can see here that the indexes definitely have a part to play in it, but you'd be wrong in saying that partitioning doesn't help. And you'll see that partitioning combined with indexing actually improves the performance significantly more than just indexing or just partitioning. So I hope this helps clarify the misunderstandings in terms of how partitioning works and what it can and cannot do. What I'd like to do next is I'd like to show you the forum where we were discussing this. Obviously, there was a heated debate on this, so I think the best thing would be to just look at it objectively, forget about all the other discussions that were going on, and just focus on the data and the reasoning behind what people were saying at that point. So I'm just going to go ahead. If you log into SQL Server Central, you can come down to, I guess if you search recent posts, you'll find it. Um, actually, I think it was called to query a large data set or something like that. Let me see if I can just find it out for you real quick. Okay, I don't know how it works with the search results here, but I'll just go ahead and show you the video. I mean, I'll just show you the links. I'll put them in the YouTube website anyway. But just a second, let me just somewhere down here, query on a large database. So you can see here that the scripts are available here. There's also the data file, this .csv file that I was using, which you can find it here in Google Drive, right? So you can pick it up from here. The topic number is mentioned up on top, so you can just type in this URL, and that should open it up directly for you in SQL Server Central. The discussion, as you can see here, we've had it going on for a long time, so you'll see that there's a lot of discussions going on here. The important ones that you probably want to go ahead and look at is within the context of this reasoning here. So you will see that to compare apples to apples, you need to create a non-clustered index on the primary key column, which was the ID column, and a clustered index on the ref age column. And that's what we did here when we created partition test 2, where you'll see that I've got a non-clustered index on the ID column, which is the primary key column that we are using, and then I've got a clustered index on ref age, and that's where we got these numbers, right? Unpartitioned table, 9 and then 436 and 21266, right? So that's basically it. I hope this video has been helpful in trying to getting things clarified. You'll also see here that summarized by age groups. There was a lot of other discussions and scenarios that we were trying to cover, but bottom line being that regardless of which way you look at it, partitioning does provide some benefit. And I hope this video has been a little bit informative in terms of understanding this concept. Thank you for watching, and I hope you enjoyed this video.